Hi everyone, welcome to the class. So this is the second session on random variables. So yesterday we have discussed few things. So regarding what is random variable, what is probability density function, what is cumulative distribution functions, and we have done some problems based on those concepts. Today we are gonna revise a few more important things regarding random variables. So this is the summary of what we are going to discuss today. All the important points I want to highlight in today's class. So I'll be discussing briefly about exponential distribution, Gaussian distribution, and Rayleigh distribution also. Specifically in Rayleigh distribution, one or two few points are important. So those things I'll be discussing, and then I'll be talking about if you can form a function of a random variable, how to find the PDF of it, and a few important observations regarding that. And also I'll be discussing briefly about joint density functions of two random variables, joint distribution function of two random variables, and using what we will be discussing here, we will also be discussing about function of two random variables, how to find the joint PDF of function of two random variables, and also problems based on that. So very interesting and little tricky discussion is involved in today's class. Hi Madhu, good evening. Deepak, good evening. Aspirant. So no job does not mean you're waste, man. Every one of us will get the job when the time comes. You just have to wait it out. Okay. So in the process of waiting, we might sometimes feel disappointed. Don't get disappointed. Everyone will have a bad phase. Maybe you are in the bad phase right now. You'll come to your good phase also will come. Nothing is permanent, right? Bad phase is also not permanent. Good phase is also not permanent. Okay, wait for your good phase to come. Okay, wonderful. So if x is an exponential random variable, I'm going to talk about exponential random. If I'm assuming x as the letter that I'm using for random variable, we can use any letter as I said yesterday. X is an exponential random variable. Whenever I say use exponential random variable, it means the random variable has a PDF which is having the shape of exponential. Okay. So this is how the shape of an exponential random variable exponential PDF looks like. So this is how the equation will be. Sir, exponential PDF means should it be always starting at 0? Not really. It can start at any place. But since it can start at any place, so I should plot something. No? So I'm plotting an exponential PDF which starts at 0. Okay. So we can talk about if a PDF starts at some other point, how will the equation look like? We can talk about that also. Okay. So for that exponential PDF, yesterday we have discussed formulas for moments, first order and second order moments. So using those formulas, you can find the mean value, mean square value, and variance. So for this random variable also. So if you find that, it's very simple answers to remember. Since exponential PDF is very important, if possible, you can remember these things. Generally, I don't suggest to remember because these are very easy to remember, and these can help you to solve few problems quickly. So it's worth remembering and easy to remember also. So mean value is whatever is there in the power of exponential random variable, whatever is in the power here beside the random variable in the power, that itself, the inverse of it will be the mean value. So this value is crucial. So whatever is the value that we are seeing here, the same value will be outside. So why the same value should be outside? Because if you want the area to be 1, that happens only if this value and this value are equal. So if you want, you can try with the different values here and here, and you can try to find the area. It will not be equal to 1 if these two are different. So that's why these two values should be same. Since this is a revision session, I'm going a little quickly. I'm not finding the area, and I'm not showing why if the values are different, what happens and all that. I'm not showing. So I'm quickly revising things. Okay. So mean is 1 by a, and mean square value is 2 by a square, variance is 1 by a square. Okay, so variance is AC power is 1 by a square, DC power is mean whole square, which is again 1 by a square. So 1 by a square plus 1 by a square, AC power plus DC power is 2 by a square, right? It is matching. Perfect. I hope you're following till this point. It's very easy points I've discussed till now. Now let me discuss something little different from what we have discussed till now, or what you know till now. Let me plot an exponential PDF which looks something like this. So if you want, you can take some other point which starts at some negative value of x also, but I'm starting at this place. Let's say this is some b as a function of y. So this is fy of y. The height will be, let me say, same a only here. Can anyone tell me how the equation looks like? I've given you the shape. Based on the shape, could you tell me the equation? Simple mathematics I'm asking you. Is this not looking like the shifted version of this? Since this is looking like shifted version of this, so if you look at it, if you look at this as some g of x, okay, so you can look at it as this is like something like g of x minus b. Can we say that? If this is g of x, this is looking like g of x minus b. The same function shifted by b units towards right side. When a function is shifted towards right side by b units, replace x with x minus b. Since the variable is y here, replace y with y minus b. Sorry, g of x minus b means, let me write it, a into e power minus a into x minus b. Perfect, this is the answer. But since I have changed the variable here, I have taken it as y. So instead of x, replace it with y and rewrite it. So it is a into e power minus of a into y minus b. Okay, if I have taken x here, this would have been the answer. Since I have taken y as the variable, why I have taken different variable is because I just want you to be comfortable with any variable. Same equation here also. Only thing is, since this is looking like shifted version of this, that's why I'm replacing the variable with instead of this equation, I'm writing, instead of x minus b, since the variable is y, I'm writing y minus b. Okay, beautiful. So here you can observe that this value and this value are same here also. Even if it is a shifted exponential function also, these two values will be same. So whenever, if they give you shifted PDF also, then the variance will not change, correct? Will the variance change? Variance is with respect to the mean value, right? With respect to the mean value, that will not change. Okay, let us find out expectation of y is equal to, so let us understand this relation. What is the relation between y and x? If you can understand the relation between y and x, then it will be easy. Y equal to x plus b, can I say that? Or x equal to y minus b, can we say that? See this one, in place of x we have replaced with y minus b. So the relation between x and y is x equal to y minus b, right? Okay, so y equal to x plus b. So if you know the relation between y and x, can you find the relation between the moments? Expectation of, replace y with x plus b, which is equal to expectation of x plus expectation of b is b. Expectation of x in this problem, is 1 by a plus b. Expectation of y square, some noise in the background, right? Give me a minute. future PSUN. I'll get back to you. Give me a minute if you're there. Expectation of y square. So how about expectation of y square? Same funda. Yesterday we have done some problems. If you know the relation between two random variables, you can find the relation between moments also. Just substitute what you know about that in place of y. Replace it with x plus b, which is equal to expectation of, just expand the inside part, which is x square plus b square plus 2bx, which is equal to expectation of x square, which we already know, which is 2 by a square, plus expectation of b square is b square only, plus 2b times expectation of this part is 2b times expectation of x, which is 1 by a. Now variance, sigma y square is equal to, what is the variance? Mean square value minus dc power, we can do this value whole square, this minus this value whole square, that is one way. Or else you can go directly also, expectation of y minus y bar whole square. This is the definition of variance of y. So what we know about y, just substitute that. Y is x plus b minus of y bar is x bar plus b bar, x bar plus b whole square. B and b cancel, so it is x minus x bar whole square, which is sigma x square. If you observe, x is added with a constant. Addition of a constant should not change the AC power. It will only change the DC power, right? So if it does not change the constant addition does not change AC power, which means it does not change the variance. I hope it is clear till this point. So any exponential PDF shifted this way or that way, it should be very easy thing to deal with. Relation between moments we can establish. You can write the equation of the PDF. Okay, if you want, you can take some other example where the exponential PDF starts at some place and try to write the equation of it with a different height. That will give you confidence. Okay. So if anyone has dropped your job and preparing, that's a good thing. While you have dropped from your job, you should have had some pretty good idea about what you are doing, right? But after few months or some people will try for few years also. After few years, because of lack of confidence, you'll forget why you have left the job. And since you forget why you are here, that's why the self-confidence reduces. Or sometimes we'll be in a mentally poor situation that even though we remember why we have left the job, but still we will not be able to focus. We'll have self-doubt whether we will achieve or not. Yes, so these are all bad phases while we are preparing. So people who can come out strong during these phases, who can be mentally strong in these phases, only will come out successful. So one thing I would suggest you is if you are feeling a lot of pressure because of dropping from job, and you're feeling a lot of pressure because of that, then if earning is an issue, then take up some tuitions, 1 hour or 2 hours a day, if possible, in and around your locality. Or online platforms are also there for doubt solving kind of thing. But don't take up, because your main goal is this exam, right? GATE or ESC or some other exam. So don't deviate from that. That is your main focus. So whatever the reason why you have left the job, that should remain the same. That should be your highest priority. But a little bit of earning might help you, give you confidence, will help you that okay, even if it takes 6 more months, 1 year more, 2 years more also, there is something to support me. Okay. So that is one suggestion that I can make. There can be better suggestions also. At this point of time, that is what is coming to my mind. Or if you're good at something, you can take up something else also, where you work only less than 1-2 hours or maximum 3 hours. Because if you work more, then you'll be tired in that and you can't focus on your main thing, which is the exam. Okay. Next, so one important thing about Raleigh random variable I want to discuss here. Raleigh random variables PDF and all that I'm not going to discuss because that's not really very important. One important point and the question that is repeated multiple times in the previous year papers, that model of problem I want to discuss. If x and y are two independent Gaussian random variables, if x and y are two independent Gaussian random variables, and you form another random variable z with this relation, root of x square plus y square kind of relation. If x and y are independent and Gaussian, both independent should happen as well as Gaussian also should happen. Both should happen, independentness and Gaussian. Then z will become a z is a random variable, right? It should have some PDF, no? And that PDF is definitely Raleigh. If x and y are not independent, then this will not be Raleigh. If x and y are not Gaussian, then also it will not be Raleigh. X and y both should be Gaussian and both should be independent also, independent of each other, right? So based on this simple point, a lot of questions were asked in the previous papers. For example, w equal to x plus ij iy or x plus jy. J means I'm talking about a complex number here, complex random variable. I formed a complex random variable w here. So how about the PDF of mod w? What about the PDF of mod w? Mod w is nothing but it is root of x square plus y square only, no? Since x and y are independent and Gaussian, so mod w will have this relation. Whenever you see this relation, you should understand that it is having a PDF of Raleigh. Okay, right. One more thing I can ask you. A few more things actually can be framed from this. X sine omega naught t plus y cos omega naught t. And here I'm asking you. Here this is a signal. Okay, this is a signal. One second. W of t, let's say, because this is a time signal, so it's time varying signal. So this is some time varying function. So then how about envelope of w of t? Envelope of w of t is also nothing but root of x square plus y square. If you know how to find envelope, you'll know why I've written this like in this manner. In analog communication, you might have learned about what is envelope of a signal. So this envelope of this signal also will have Raleigh PDF. Like this, let them give any form of equation. If it whatever they're talking about, it has a relation in this format, root of one random variable whole square plus another random variable whole square, then it will have a Raleigh PDF. Raleigh PDF looks very complicated. I mean the mathematical equation also. So framing questions based on calculations is rare, because it will take a lot of time if they give some mathematical calculations based on Raleigh. So they'll give you some theoretical questions in this format. Right. So one more important point I want to revise here. Mean of a random variable which has a probability density function which has symmetry with respect to any vertical line is the value of random variable on the vertical line. So what I mean by this? See, PDFs, not all PDFs are symmetrical, correct? But certain PDFs are symmetrical, no? With respect to some line. I'm not talking about symmetry only with respect to y-axis. I'm talking about symmetry with respect to any vertical line. Some shapes are symmetrical, right? Triangle is symmetrical. Rectangle is also symmetrical, right? Rectangular signal, rectangular graph, and Gaussian is also symmetrical. Like that, if you can talk, if we can, if you see some symmetrical PDF, I'm not talking about even symmetry. Okay, I'm not talking about even symmetries. Even symmetry means symmetry with respect to y-axis. I'm talking about a signal which has symmetry with respect to any point. I'll just give you examples. Okay, for example, A random variable x goes from 3 to 11 fx of x. So is it symmetrical? I'm not talking about even symmetric. Definitely this is not even symmetric, but it has symmetry with respect to some midpoint of the rectangle, right? And what is that midpoint? The average of these two, 3 plus 11 by 2, which is 7. With respect to 7, it is symmetric or not? It has a length of 4 units this side and 4 units this side. Correct? If you stand here and look at this side and look at this side, shape of the signal is same. Shape of the graph is same, right? So since we know PDF area should be 1, so it should be 1 by 8 should be the height. So since it is symmetrical with respect to this vertical line, what is this vertical line? X equal to 7 line. X equal to 7 line, we have symmetry. With respect to x equal to 7, symmetry is present. Correct? Right. Since there is symmetry with respect to 7, since this is a symmetrical PDF with respect to some vertical line, so for this PDF, we can say the mean value very easily. We don't need to do mathematical calculation. But we always know how to do mathematical calculation. Expectation of x formula, we know. Integration of x into fx of x dx. You can use that always. But in some problems where symmetry is there, if you are able to see the graph, if there is symmetry, then you can recognize it very easily. You can save a lot of time. So, and in this case, it is 7. If you want, you can go with normal procedure also. That also will give you the same answer. One more question. One more example. Any symmetrical thing. Four and 8. What should be the height here? Let's say this is y. Fy of y. The height should be in such a manner that the area should be 1. If you want the area to be 1, height should be 1 by 4. Area of this triangle is 4 units. I mean, area of the triangle is height can be anything. Okay, if you are, how did I find 1 by 4? Just by finding the area, so that it should be 1. Let us just assume height as b and find the area. Area will be 4b. If you want 4b to be 1, b should be 1 by 4. Okay. Right, now if you observe, this also has symmetry with respect to 4, no? With respect to 4, it is having, this shape is symmetric. Hence, if you want to find the mean value of this random variable, whenever you find symmetry with respect to some vertical line, you can calculate the mean very easily. Other things are not so easy, but mean value is very easy. Okay, right. Next, one more example is Gaussian. I'll talk about Gaussian a little bit more in the next slides. Let's say this is Gaussian PDF. Both sides it is symmetric. I may not be able to plot perfectly symmetrically, but it is symmetrical shape. You might be knowing about Gaussian. Z. Let me say this is f z of z. Let me say this, it is symmetric with respect to 8. So could you tell me what is expectation of z from the point that I've told you here? If you are seeing any PDF which has symmetry, some kind of symmetry, exact symmetry should be there. Okay, little bit different, no, not possible. So here you might say that, sir, it is little bit different. The way I have plotted it is slightly different, but this is Gaussian shape. It will be equal both sides. It has symmetry with respect to 8, with respect to z equal to 8. So mean value will be 8. Is it okay? Fine. So there can be other shape without symmetry PDFs also will be there. No, something like I'll give you some triangle shape itself, but without symmetry. Something like this. Let's say this is 2 and this is 7. Y1, let's say. This is the PDF of Fy1 of Y1. So is this having any symmetry? No symmetry. With respect to 2, definitely no symmetry. There is no symmetry here, right? Since there is no symmetry, can we not find mean? We can find mean. For any random variable we can find mean. We have a procedure. But By using this point, we can't find the mean quickly here. There is no easy way of finding the mean here quickly. We have to go with the mathematical procedure, which is expectation of y1, which is integration of y1 into fy1 of y1 dy y1. Using that mathematical procedure, you have to find it, which is easy. You know the procedure, you can do it. You can take this as homework and do it. But there is no symmetry here. Because there is no symmetry, it's not easy to recognize directly by looking at the graph. Okay, so like this, if they give you any non-symmetrical PDF, non-symmetrical with respect to any line, there is no line with respect to it is symmetric, then we can't recognize the mean value just by looking at it, but we can find using the formula. Definitely using mathematical equation for a mean value, we can find it. Okay, wonderful. So this is a beautiful point. Wonderful point. I hope it is clear. One more example I want to give. So what is it? What PDF is this? Anyone? I'm not really good at drawing, so I just kindly adjust with my drawings if they are not very clear. But I think I'm reasonable enough to be able to understand. Q. Let me say the random variable is Q here. F Q of Q. So how is this looking like? It is symmetrical or not? Is it symmetrical or not? It is definitely symmetrical, right? Correct? Huh? It is symmetrical with respect to 0 line. It is exponentially decreasing signal both sides. So what is the mean value of this random variable Q? What is the mean value of this random variable Q? Expectation of Q is equal to, anyone? It is symmetrical with respect to Q equal to 0 line. So hence mean value is 0. Correct? Very good, Aditya. Wonderful. I'll give you one homework here. Right. Let me give you the height also. Height is 4 units. Write equation of FQ of Q. If you can write this, you are amazing. This is your homework. Okay. So you can post it in the comments after the class once you have done it. Okay. Not in the live chat, later in the comments section of this video, or you can, if you want to cross check if it is correct or not, then you can post it in our Telegram channel also, Telegram group also. I hope you know the Telegram group. Electronics by Dinesh Gutha sir. You can type, you'll get it. Okay. If there is anything not clear for you guys in any particular topic, you can just revisit that part of the video again and just watch that part of the video so that it will be clear. Because things, if you are not aware of that particular thing earlier, then it might seem little tricky. So for that part you can watch it again, and other things should be fine. Very good. So this is Gaussian random variable. So Gaussian random variable is the most important PDF that we have in communication, not only in communication, in every practical scenarios. Gaussian random variable is the most important PDF. We also call it as normal distribution. Okay, since you're talking about random variable, it will have a mean and variance. Okay, I think Deepak, you are right. So here normal distribution, since it's normal distribution starts with the letter N, Gaussian distribution or normal distribution, both are same. So normal since they represent it with the letter N of whatever they give in the first place, that is the mean value, and whatever they give in the second place, that is the variance value. So in a Gaussian distribution, since it is a symmetrical PDF, the line with respect to which it is symmetrical, that line, on that line, the value of the random variable is nothing but the mean value. Can I say that? So what is the mean value here? A. So in this graph, can I say this is A? Mean value can be anything. I have taken it as a letter A in this example. Okay. So could you tell me the equation here? I hope you know the equation of PDF, right? Gaussian PDF. The general equation I'm writing. I've taken a general PDF here. I'm not taking with symmetrical with respect to 0 axis. Okay, I'm taking a general Gaussian PDF. 1 by root of 2 pi sigma square, whatever you remember, just I'm rewriting it. E power minus of x minus x bar whole square divided by 2 sigma square. This is the general Gaussian PDF equation. Okay, very good. So in this case, in this particular example, since I have taken mean value as a, replace x bar with a and replace sigma square with b. 1 by 2 pi b into e power minus of x minus a whole square divided by 2 sigma square. In place of sigma square, it is b here. Generally, this is the equation. You just remember this. If the mean and variance are given, you just need to substitute here. You can substitute the mean here, and here you can substitute the variance. So what is the height of this? It is 1 by root of 2 pi sigma square, we can say, or in this case it is 1 by root of 2 pi b. Okay, wonderful. Now let me ask you a few questions here. Let us analyze few things here, very important things. Okay, so what is expectation of x here? Expectation of x, in this case it is a, and sigma x square is b. Could you tell me what is expectation of x square? In this, expectation of x square is not directly given, but we can find it. Right, it is variance, which is b, ac power plus dc power is a square. Okay, very nice. Next time I'm going to ask you one more thing. What is the probability that the random variable x takes a value a? How much? Anyone? The probability the random variable takes all the values from minus infinity to plus infinity with the different probabilities. At a it has higher probability, and as you go far from a, the probability decreases. As you go away from a, the probability decreases. Can anyone tell me what is the probability that x equal to a? Anyone? Come on. Wonderful. X equal to 100. Anyone can tell me this one? How about fx of x equal to a? I'm talking about fx of x equal to x bar. I'm talking about the functional value here. At x equal to a, what is the height here? We have written it, no? Or you can substitute here. X equal to a, if you substitute e power, it will be 0, which is e power 0 is 1. It will be 1 by root of 2 pi b, correct? 1 by root of 2 pi b, or 2 pi sigma square you can write. But here functional value is different. Functional value is what appears as height. Probability is probability at a particular point. Always I told you, analyze it like this: a minus less than x less than a plus. Probability at a can be looked at as probability from a minus to a plus, which means you just need to find the area from a minus to a plus. What is the area from a minus to a plus? This area. What is this area? Height is this one, 1 by root 2 pi sigma square, but width is almost 0, so the probability will be equal to area from a minus to a plus, almost 0 area. So the answer is approximately 0. Very small value, which we can write it as, in the options we will not be seeing a very small value kind of options, but if they give us infinitesimally small value, that is the perfect answer to write. But since we generally will not find that kind of options, we can write it as 0, approximately equal to 0. How about this one? Probability at any point, and 100 also. At 100, the height is non-zero, but the probability means it is the area at that point. From 100 minus to 100 plus, the area is 0. Probability at any particular point in a continuous PDF generally is 0, except in one situation, and that situation is probability at a particular point is non-zero in a continuous PDF only if there is an impulse at that place. If there is no impulse in the PDF at a particular point, then probability is 0 at every point. Pardhuman Gupta, yes, definitely I'll provide the PPT. Pardhuman, I'll share it in the Telegram group. Okay, you can search with my name. You'll find a Telegram group. There definitely after, just immediately after the class, I'll share the PDF. Okay, am I clear with this? So they can ask these kind of questions. So one more thing I want to analyze here, the CDF. We know the PDF, no? So shall we draw the CDF? Let's draw the CDF. CDF means what? It is accumulation of PDF. It is integration only, no? Yes, Deepak has provided the name of my Telegram channel. So as if you integrate this, what happens is, when you integrate a signal, what happens is the amplitude of this signal will become the slope of the integrated signal. Okay. So as you come from minus infinity, what happens? The area is increasing. The area is increasing. The area is increasing. At A, what happens? At A, the area increases till A, and after A also there is a positive accumulation. Only positive area is accumulating more, right? But the amplitude here will become the slope here. Since the amplitude is highest at A, that will get converted to slope at A here in capital Fx of x. It will get converted to slope. The amplitudes here will get converted to slopes here because we are doing simple integration. Right. So since the amplitude is highest at A, the slope should be highest at A. Slope should be highest. And after that, the amplitude decreases, the slope also decreases. Slope. See the slope? Am I decreasing the slope or not? And slowly the slope goes to 0 because the amplitude here goes to 0. In integrated signal, slope should go to 0. Slope should go to 0 means it should become constant. This is how the CDF looks like for a Gaussian PDF. Just with common sense, you can plot it. The height at A, yes, very good Deepak. At the height at A, the height in CDF is nothing but the probability accumulated till that point. What is the probability accumulated till A? Since it is symmetrical, till A half of the area is there. Total area is 1 here because it is PDF, total area is 1. Till A, half of the area will be there. So at mean value, CDF function value will be half. And finally, after large value of s of x, it will become 1. From the properties of CDF, we know, that after certain value, it will become constant and equal to 1. Okay. Is the video clear? Is the video and audio clear? Just can you update me? In my phone, it's not clear. Maybe I don't know why. So this is the basic understanding of Gaussian random variable. So I want to discuss few more important things about Gaussian random variable. So let me talk about Gaussian random variable with certain mean and certain variance. So a Gaussian PDF with mean as 0 and variance as 1, Gaussian random variable with mean as 0 and variance as 1, we call it as normalized Gaussian density function. I am calling it as normalized because I've made mean as 0 and variance as 1. Just for our convenience, we are talking about this normalized Gaussian distribution function because in many practical situations we have this normal distribution or Gaussian distribution. For example, our noise is also having Gaussian PDF. Okay, but if you observe the equation of the mathematical equation of this PDF, it's complicated. If you want to perform some integration on this or integration on this or some kind of area if you want to find for this graph, it will be difficult to find. It's not so easy to find it. Okay, so that's why using some mathematical procedures, if you want to find the area, it is difficult to find the area quickly. So that's why in our textbooks or wherever required, there will be tables provided in the form of F tables or Q tables. They'll be providing tables. Using those tables, we can find the areas of this graph easily. How? I'll tell you. since if they want to provide the tables for every mean and every possible combination of mean and variance, it's difficult to provide. So that's why they will provide the tables for only for normalized Gaussian distribution or Gaussian distribution with mean 0 and variance 1. They'll provide for this particular Gaussian distribution function, and using that information we can extrapolate for other Gaussian distributions also. How? We'll see. Say this one. So the mean is 0, so it is symmetrical with respect to 0 value, x equal to 0. And variance, what do I mean by variance? I'll explain a little bit here. For a Gaussian distribution especially, let me talk in general terms here. Instead of A, let me talk in general terms. X bar is the mean, so this is x bar plus sigma, and this is x bar minus sigma. So I hope you might have learned somewhere what is the area in this region. What is the area in this region? From x bar minus sigma to x bar plus sigma. From the mean on this side sigma distance and this side sigma distance, what is the probability that the random variable takes values in this range? The area here is 68% of the total area is considered only in this region, or the area of this region is 0.68, or area is 60% of the total area. And similarly, x bar minus 2 sigma to x bar plus 2 sigma, what is the area in this region? The area in this region is 0.95. Similarly, till x bar plus 3 sigma, if you want to find the area, it will be 0.99. Most of the area is contained within the 3 standard deviations on both sides. Okay. The same funda, if you translate it to here, 1 standard deviation on this side and that side, minus 1 to plus 1. For a normalized Gaussian, standard deviation is 1, which means variance is also 1. 1 standard deviation this side and that side. What is the area? Always the same. For any Gaussian PDF, it's the same. 1 standard deviation on either side of the mean, the area will be 0.68. 1 standard deviation on either, 2 standard deviations on either side. What is the area? The area will be this total area from minus 2 to plus 2 will be 0.95. Similarly, from minus 3 to plus 3, the area will be 0.99. Okay, right. So could you tell me what is the equation of the PDF in this case? Could you tell me? The equation of the PDF is 1 by root of 2 pi sigma square. But in this normalized Gaussian, sigma square is 1. So I'm replacing sigma square with 1. Into e power minus of x minus x bar is 0 here. So it will become x square by 2 sigma square is 2 1 square, which is 2. So the equation looks very simple for a normalized Gaussian. Very simple equation. Easy to remember also. It is a symmetrical graph with respect to 0. That's why the mean is also 0. Fine. So how about the CDF? We can plot the CDF also. The mean value is 0. At 0, the height of the CDF will be half, as we have discussed previously, because half of the area is there till 0. CDF consists of accumulated probability. Till 0, we have half of the area, so the height here will be half. And if you plot the graph, the amplitudes here will become the slopes here. So if you integrate this, we don't need to plot the exact shape. Roughly, if you can plot the shape, that is sufficient. Since the amplitudes are increasing, the slopes also should increase. Slope is increasing. Here it is becoming maximum slope because the amplitude maximum here. And after that, the amplitude is decreasing. So if the amplitude decreases, slope should decrease. Slope should decrease. Slope should become 0. Slope should become 0 means it should become constant, something like this. The height here, the maximum height possible in any CDF. In any CDF of any random variable, the maximum height possible is 1. And it can never take negative values. Because CDF and PDF, we are talking about only probabilities. Probabilities can never be negative. Okay, right. So what is the relation between a general Gaussian distribution function? What is the relation between general Gaussian distribution function and normalized Gaussian distribution? This is general Gaussian distribution with any mean, any variance, and I'm talking about this one. So this two should have some relation, right? Correct or not? So if you shift this by b units towards right side and scale this, scale this by sigma times, then definitely we can say that these two are related. No, so this one, if you compress and shift it, you'll get this one or not, right? So there is a relation between the normalized Gaussian and general Gaussian. So which means their CDFs also should be related. We can easily derive it in the regular class. Generally I'll derive it, but since this is revision class, I'm not going to derive it. I'm going to give you the relation. See, I have taken different notation for normalized Gaussian. I did not take the subscript x just to show the difference. F of x is the CDF of normalized Gaussian random variable. How do we find this? How do we find this? It is fx of x is equal to f of x minus mean value x bar divided by sigma. This is the relation between CDF of any Gaussian random variable and CDF of normalized Gaussian random variable. Very simple relation, you can remember this. We can easily derive this relation also. We can easily derive this relation. It's not so difficult, it's so easy. You can try that later if you want to derive it on your own. So you have this graph, you have this equation, you have the other equation, write the CDF equation, write the CDF equation of general Gaussian distribution, and try to find the relation between them using your basic mathematics. You can get this result. Okay, so capital F of 1 or capital F of 1.5, 1.7, 1.8, 2, capital F of 2, all these values are provided in at the back of our textbook in the appendix. So F tables or Q function values, these will be given. So if you know these values, then you can find the CDF. Let's say if you are talking about fx of 5, let's say I'm talking about fx of 5, then there is no table for any general Gaussian distribution. We have tables only for normalized Gaussian. So if you want to find this, what you can do is you can write as f of, from this relation, 5 minus, what is the mean value of x? You just write that here. What is the standard deviation of x? You can write it in the denominator. You'll get some value, no, based on x bar and sigma. You'll get some f of 1 or f of 2, something like that. That you can search through the table and you can find it, no. Even in the exam also, if they are talking about some Gaussian distribution and if they want some numerical answer, they'll give you these f values or q values. Okay, fine. So this is a very important relation, right? So how about the relation between f of x, f of minus x, q of x, q of minus x, f of fx of x? Just now we have understood what is the relation. Fx of x is equal to f of x minus x bar divided by sigma. I hope you remember the difference. When I have taken the subscript for a general random variable, without subscript means it's a normalized Gaussian random variable. Okay, right. So everyone knows what is capital F of x. This is normalized Gaussian. This is normalized Gaussian random variable. This is normalized Gaussian random variable, and you know the equation for the PDF, 1 by root 2 pi d power minus x square divided by 2. So let me define what is, you already know what is f of x. F of x is nothing but CDF of normalized Gaussian. CDF means what? P of capital X less than or equal to small x. You are interested in all the values from minus infinity to small x. So you just integrate minus infinity to small x, fx of x dx, which is this PDF integrated from minus infinity to small x because you are interested in accumulated probability till x. 1 by root 2 pi into e power minus x square divided by 2 dx. Okay, so what it means is, let's say this is some x naught. Let me take it as x naught so that there will be more clarity here. X naught, whatever is the value here, that should be the upper limit here. Let's say this is x naught. So CDF means f of x naught means it is this area. It is this area. This area is what we call as f of x naught. The CDF value, the CDF function value at x naught is the area of PDF from minus infinity to x naught. Next, q of x is defined exactly the opposite way. Q of x naught is p of x greater than x naught. It's just the opposite. The remaining area in the Gaussian PDF, in the normalized Gaussian PDF, the remaining area or else the area from x0 to infinity. That is what we call as q of value, q of x, or q function value. Integration from x0 to infinity. We are interested in values from x0 to infinity. 1 by root 2 pi into e power minus x square divided by 2 dx. So they're talking about this area, they're calling it as q of x0. If they're saying q of y0, it means area from y0 to infinity. F of y0 means area from minus infinity to y0. Okay, so what about f of x0 plus q of x0? Can you tell me this? If you add up f of x0 this area and q of x0 this area, we know the total area is 1. You are getting the total area of the PDF now, so it should be equal to 1, which means we have established the relation between q of x0 and f of x0. If you know f of x0, subtract it from 1, you'll get q of x0. Or if you know q of x0, subtract it from 1, you'll get f of x0. Okay, so that is the relation between f function and q function. Next, how about the relation between f of x and f of minus x? So f of x0 means this one. How about f of minus x0? F of minus x0, try to understand it graphically also. Graphically, f of minus x0, if this is x0, minus x0 is symmetrical point with respect to 0. This is how minus x0 will be. So I have assumed that x0 is some negative value, so minus x0 is some positive value, right? So this one. So f of minus x0 means this total area, the red one, the area till this point, this total area is f of minus x0. F function value means what? Area till that point, area till the inside point, inside value. So area from minus infinity to minus x0 is f of minus x0. Okay, so this area, is it also same as this area? See this one, x0 to infinity. Since this is symmetrical PDF, this area is same as this area, right? So this area, okay, this area, see this one, area from x0 to infinity, it is nothing but q of x0. Area from x0 to infinity is q of x0. Area from minus infinity to minus x0 is f of minus x0. So these two areas are same because this is a symmetrical PDF. So the relation between, one more relation between f of x0 and q of x0 is f of minus x0 is equal to q of x0, or q of x0 is equal to q of minus x0 is equal to f of x0. There are, okay, this is the relation. One more relation. What is the relation between f of minus x0 and f of x0? See this one, f of x0, this is f of x0. F of minus x0 means this total area, this total area. What is the relation between this area and this area? If you observe this area, which is q of x0, sorry, q of minus x0, this area, see this one, this area is q of minus x0. We already know f of x0 and q of minus x0 are same, right? I want the relation between f of x0 and f of minus x0. How about that? This area is f of x0, and how about f of minus x0? This is f of minus x0, or this area is also same as f of minus x0. So this area, which is f of minus x0, and this area, which is f of x0, if you add both of them, it will result in 1. Which means if you want to find f of x0, it is 1 minus f of minus x0, or if you want to find f of minus x0, it is 1 minus f of x0. Very simple relations. If at all, if you forget also, you can plot the graph and you can get them. So generally we don't forget them. If you are forgetting means you are not very clear on that, you have to try to do it on your own again so that you'll not forget it. These relations are really important, because in the options you might find the answer in terms of CDF value, something like you got the answer as capital F of 2, but in the options you may not find f of 2, you might find it in terms of q of 2 or f of minus 2, something like that, 1 minus f of minus 2. So if you know these relations, then only you can find the right option, because the answer that you got, the format in which you got, that option may not appear in the options. right? So that's why these relations are important. So that is a quick revision on Gaussian distribution, f function values and q function values. And there are other ways of representing these areas. The area from minus infinity to x naught and x naught to infinity, we are writing them as f of x naught, f of x and q of x, right? Similarly, there are two other functions. If you are interested, you can explore them through internet also, or you might have already known them: error function and complementary error function. Error function of x, complementary error function of x. So these have similar equations, not same. These have similar formulas as f of x and q of x. Not same, but similar, very close relation. Fine, I'm moving ahead with other topics. Okay, fine. Fine. So let us talk about moments of two random variables. In yesterday's class, we have talked about moments of one random variable. So we can talk about moments of two random variables. We can define lots of moments. We can define second order, third order, fourth order, fifth order moments also. But only one moment is important for us, and that is second order moment. There are two types of second order moments. One, we call it as correlation between two random variables. One, we call it as correlation. We represent it as R subscript xy, and another one is Cxy, which we call it as covariance. What is the meaning of this? The meaning of Rxy. This is the notation that we follow. Okay, in an exam, they might take some other notation also, but generally this is the followed notation in many textbooks. So Rxy, the definition of it is expectation of x into y. X is a random variable, y is a random variable, xy is another random variable. That product xy is random, right? So since it is random, we don't know how to analyze it. So that's why we want to find an average value of product xy. So an average value of product xy is what we call as joint moment or second order joint moment of x and y, or we can also call it as correlation between the random variables x and y. Okay, right. How about Cxy? Cxy is also similar second order moment, but we're going to subtract the moments, subtract the mean values from the random variables and then multiply. This product x minus x bar and y minus y bar product, the average of that value, average of that product, we call it as covariance. Okay, so what is the importance of these two moments? So these moments will give us the relation between two random variables. How much related are they? How much relation is there between two random variables? That is given by this correlation and covariance. And how about the relation between these two, Cxy and Rxy? Cxy is equal to expectation of, see this one, x minus x bar into y minus y bar. If you expand it, it becomes xy minus x bar into y minus x into y bar plus x bar into y bar. So first part is expectation of xy, which is same as Rxy, and second part is x bar is a constant. If you apply expectation, this constant can be pulled outside. If you apply expectation, it becomes expectation of y, which is y bar. So it becomes y x bar outside. If you apply expectation, it becomes y bar minus, for this one, if you apply expectation, x bar into y bar. This is a constant already. If you apply expectation also, it will be same. We cancel it. So what we got is the relation between Cxy, covariance and correlation is, this is the relation. Difference between both Okay, so both are giving some kind of relation. Okay, rxy and cxy both are giving some kind of relation. They are trying to establish the how similar are x and y. The difference is here we are trying to find the relation between the random variables x and y, and here we are finding the relation between x and y by centering them. By centering them means like we're subtracting the mean values, right? We're subtracting the mean values. So let's say I generally take this example. If I want to compare the height of two people, I have to, if I bring them to the same platform and then compare the height, then that is when I get the correct relation, right? So this is similar to that. So I'm subtracting the mean and I'm trying to find the relation between them. This cxy is that kind of comparison, putting them on the same platform or shifting them to the same level and then trying to compare them, trying to find the relation. And this is like without shifting you are trying to find the relation, so something like that. Okay, okay, so what is the importance of these things? Let me explain. So I hope you know how to find Venkatram, we will see. We will plan. So entire planning is not on my side. So our team will plan based on students' request or how many students are interested in what topic. Based on that, they will decide. So definitely, I'll put that forward by request. We'll see if the team plans the same thing. If they also want me to take the noise analysis part, I'll take it definitely. Okay, right. So if you want to find this mean value moment, so how do you find it? So since there are two random variables are involved here, x and y, since two random variables are involved, what should we multiply with? If only one random variable is involved, then we'll multiply with first order PDF. If two random variables are involved, we have to multiply with the second order PDF of x and y, fxy of x comma y. Since two variables are involved, expectation if you apply, you should get a constant. Well, how will you get a constant? There are two random variables, so we will get a constant only if you do double integration. Double integration. Limits will be from minus infinity to plus infinity. Okay, right, wonderful. Now let me tell you the important points regarding this correlation and covariance. Same funda, correlation and covariance we will discuss in random process also, but their concept is same, but we just generally we call it with a different name. As instead of correlation we call it as autocorrelation in random process. Instead of covariance we call it as autocovariance in random process. If rxy equal to 0, what does that mean? What is the relation between x and y called when rxy becomes 0? X comma y are orthogonal random variables. Orthogonal random variables. That is how it is named. Okay, so it means this product is random in nature. If you average that product, if that average turns out to be 0, we say the relation between x and y is orthogonal. If you remember orthogonality between signals also, what is if you remember orthogonality of two signals, make the product of the signals and integrate. If it becomes 0, we say the signals are orthogonal. No? Here also similar thing is happening. Product, you're trying to find the average of the product, and that is turning out to be 0. Hence similar name, orthogonality. If cxy is equal to 0, what is the meaning of cxy becoming 0? If cxy becomes 0, it means rxy and x bar into y bar are same. If cxy becomes 0, then rxy becomes equal to x bar into y bar, or expectation of x into expectation of y. Both are same. These two are same. If this happens, this will happen. Okay. So what is the relation called when this happens? When covariance becomes 0, x and y are uncorrelated. Uncorrelated. Sir, when covariance becomes 0, you are calling it as uncorrelated? Yes, because rxy also finds correlation. Cxy is also finding correlation only, but you are removing the mean values, which means you are recentering them, you are putting at the same level. By removing the mean, you are putting at the same position, I mean same center, and you are trying to compare. So that will give you the exact correlation, right? So that's why we call it as uncorrelated. When covariance becomes 0, then only we call the random variables as uncorrelated, not when correlation becomes 0. Okay, and if x bar or y bar, one of them is 0, then what can we say? If x bar, one of the moments is 0, one of the mean values of x and y, one of them is 0, not both of them is also fine. If one of them is 0, then cxy and rxy are same, no? Cxy and rxy are same. Correlation and covariance will become same if mean value of one of the random variables involved is 0. So orthogonality and uncorrelatedness will become exactly same if mean of one of the random variables is 0. Okay, I hope it is clear till this point. Now let me make one more relation. There is one more relation: orthogonal relation, uncorrelated relation, and one more thing is independent relation. Very important relation. Mostly problems are asked based on this independent relation only. If x comma y are independent random variables, let me revise this point quickly, are independent random variables. If x comma y are independent random variables, then what is the point that we can say? fxy of x comma y, when two events are independent, you can just recollect a point from your basic sets and relations also. P of A intersection B, or some from your basic mathematics probability also. P of A intersection B can be written as P of A into P of B. This happens if A comma B are independent. No? If A comma B are independent events. What I mean by independent events? Happening of A is nowhere going to impact happening of B. A and B happening does not impact each other at all. In that scenario, we can call them as independent. When two events are independent, what we can say is their joint probability equal to multiplication of individual probabilities. Simple example: two coins you are tossing. What is the probability of getting head on one coin and getting a head on another coin? Getting a head on one first coin is nowhere going to change what we are going to get on the second coin. So getting a head on the one coin is one event, getting a head on the second coin is another event. So these two events are not gonna impact each other. First coin coming head is nowhere going to change what is going to come on the second coin. So that's why these two are independent events. If I ask you what is the probability that we get a head on the first coin and head on the second coin, I want the joint probability. That is the probability of that head. We get head here and head here. When you want joint probability, what do we do? Find the probability here, find the probability here, and just multiply them. Okay. Whenever you are talking about independence relation, joint probability is equal to product of individual probabilities. Say whatever we do for events, same thing we do for random variables also. Fx of x is the probability of x random variable. Fy of y is the probability of y random variable. So joint PDF can be written as multiplication of individual PDF. Joint probability can be written as multiplication of individual probabilities. Same way, joint PDF can be written as multiplication of individual PDFs. So this is the most important relation regarding two random variables. If two random variables are independent, joint PDF equal to multiplication of individual PDFs. If this happens, what all can you say? Joint moments, expectation of xy. If you want, you can write integration of x into y into fxy of x comma y dx dy. That if you can replace it with this, then you can write as expectation of x into expectation of y. If x and y are independent, not only the joint PDF equal to joint multiplication of individual PDFs, joint moments are also equal to multiplication of individual moments. Not only this will happen, x square y square. Say this: if x and y are independent, x square and y square, what is the relation? That also will be independent. No, if two random variables, x square random variable and y square random variable, are also independent of each other, if two random variables are independent, their joint moment also will be equal to multiplication of individual moments. Like this, you can write expectation of cos x into sin y. That also can be written as expectation of cos x into expectation of sin y. Like this we can write 100 things. Like this we can write 100 things. Okay, so right, so try to understand this carefully. Rxy means what? Expectation of xy is equal to x bar into y bar. No, when x and y are uncorrelated, only this thing happens. Expectation of y is xy equal to x bar into y bar. First second order joint moment equal to multiplication of individual moments. This is also happening for independent case also, but for independent case there are many other things that are happening. For uncorrelated case only this is happening, right? So try to understand, if independent, there is independent relation between random variables, this is happening. If this is happening, we know the relation is uncorrelated, which means when two random variables are independent, they are also uncorrelated obviously. When they are independent, whatever is the relation for uncorrelatedness, that is also happening. No, but if I say that if two random variables are uncorrelated, can I say that they are independent? If two random variables are uncorrelated, we know that this happens, but we are not sure whether this happens or not. So when two random variables are uncorrelated, we can't guarantee independent relation. They might be or they may not be. But if two random variables are independent, they are also uncorrelated. There is only one special case where if two random variables are uncorrelated, they will also be independent, and that special case is if x comma y are Gaussian and uncorrelated. Gaussian and uncorrelated, then in this special case, when they are uncorrelated, we can't guarantee independent relation. But if they are uncorrelated and both the random variables are Gaussian, then x comma y are also independent. This is the only special case where if you know that they are uncorrelated, the special case is Gaussian case. For a Gaussian random variables, if they are uncorrelated, they are also independent. Okay, is it clear to this point? Can I move forward? Okay, so I'll tell you. See, first part is analog communication. So generally people call it as digital communication, but generally I classify communication as three parts, which is after digital communication, one more part is random variables, random process, and noise analysis in analog and digital communication. Noise analysis in analog communication and digital communication, generally people classify this thing, third part also under digital communication generally, which is not correct, but anyway, that's fine. So generally in analog communications, we can expect one to two questions. Generally we are expecting 1 to 2 questions guaranteed, 1 to 2 questions. And in digital communication, you can expect maybe 2 to 3 questions. So this is the part where we can expect more questions. 3 to 4 questions are possible here, or more also is possible. So highest weightage topic is random variables, random process, and noise analysis and overall communication. Or if you are thinking that digital communication, this also comes under digital communication, then digital communication will have more weightage. Okay, forget about weightage. You prepare whatever you have to prepare. No, it's not in your hands. No, see, last year what the questions they have given questions in some topics, and some it may happen that they may not touch those topics. They might give entirely different topics, but it will be part of the whatever the questions they give us, it will be part of the syllabus only. No, So my suggestion is, don't focus on what areas they will give questions. Okay, if they are giving more questions in that area, means it has it is a bigger topic definitely. Okay, so don't think that nothing anything something will be easy. So if something is easy, then there will be less weightage from that. There are very few topics where it is easy, but there are reasonable number of questions from that. So random variables, random process, generally if you learn from me, I have taken for around 75 to 80 hours in the last course that I've taken. So which is a lengthy course. To cover each and everything, it takes lot of duration. Since it is bigger topic, obviously weightage is bigger. Okay, so don't focus on the weightage, don't focus on particular areas. Okay, that is not going to make you a ranker. So try to focus on each and every area. Don't have partiality towards certain topics. Fine. So focus on each and every area, don't neglect any area. If you don't have time, then definitely go with the easy subjects. Go with easy subjects like control systems, digital circuits, and one more, networks. So but preparing only few subjects means I don't expect getting it ranked. Definitely it's not possible. So if you are leaving a subject, means your chances of getting a good rank has reduced significantly. Okay, by now your preparation is almost over. Don't get demotivated if I'm saying that, but give your best efforts. You'll be scoring whatever your effort deserves, definitely. Debashish, yeah, that might happen in future, Debashish, because I'm very new to this company, BYJU'S Exam Prep. I have joined very recently, few days back. So in future they might provide me digital board. So now I'm sitting in my chair and I'm using pen tab to do the class. So if they provide me the smart board, then I'll be able to do that, whatever you are asking. Okay. So let us talk about quickly about joint PDF and joint CDF of two random variables. I'm not going to talk about the derivations. I'm just going to quickly revise the relationships. Good, Venkataram. So one more the point I want to add here is, see, we have done some average preparation due to our circumstances. Maybe you are doing job or you are not able to focus. You are not able to prepare very well. So if you are not able to prepare very well, then don't expect a very good result. No, if you are expecting very good result, obviously you'll be disappointed. Let be reasonable in your expectations. No? Don't expect good results without good efforts. If we are expecting, we will add more unhappiness to our lives. So joint PDF and joint CDF. So joint PDF, we write it. The notation is generally like this: fxy of x comma y. Joint CDF notation is, we use the capital letter here. It's a second order function, or a function of two variables here. It's a function of two variables. So can you tell me the relation between these two? So before that, I'll also write the two in the first order PDFs involved, fx of x and fy of y. This is the information of x, probability information of x. This is the probability information of y, and these two will provide the probability information of x and y together. Now we need to understand or remember the relationships between these four things. And what is that relation? Fxy of x comma y is equal to, this is joint CDF. The meaning of it is probability that x less than or equal to x. So whatever is the value here, that will be here. If this is x naught, this will be x naught, comma y less than or equal to a small y, comma here represents intersection. Intersection means and. This should happen and this also should happen. The combined probability. So how do we find this? Here we are interested in the values of x from minus infinity to x, and we are also interested in the values of y from minus infinity to y. So since we are interested in the values of x and y from minus infinity to x and y, so we are integrating this function, the second order function of two random variables. We are integrating this in these limits because we are interested in the x and y values in this range. So that's why we are integrating with respect to x ones and with respect to y ones within these limits. This will give us the relation between joint CDF and joint PDF. Okay, so how about the reverse relation? The reverse relation, double integration of this has given us joint CDF, which means double differentiation of joint CDF. Double differentiation of joint CDF should give us joint PDF. Dou capital F of fxy of x comma y. Dou means partial differentiation. Once you differentiate partially with respect to x and then with respect to y, the order is not really important. Any order is fine. You will get the same answer. So we got the relation between joint PDF and joint CDF. If you know one, you can find another. Okay. Generally, you'll not be asked such questions in GATE exam because it is time consuming. Even if they ask you, they'll give you some easy function or some function where you can recognize the answer easily. They'll not involve complex calculations because it's a time limited exam. Okay, wonderful. So how about fx of x? Can you tell me? How do you find fx of x? This information, this is probability information of x. This has probability information of x and y. How do you find first order PDF from second order PDF? How do you find it? Just eliminate y from the joint distribution function. Eliminate y. How do we eliminate y? You integrate with respect to y in the limits from minus infinity to plus infinity. That will give us the first order PDF. In a similar manner, if you want f small y of y, fy of y, so let us eliminate x from joint density function. Integrate fxy of x comma y with respect to x in the limits from minus infinity to plus infinity. X gets eliminated. It will become only a function of y. So which is same as fy of y. So if you want first order density function, just integrate that with respect to other random variable that you are not interested in. You'll get the first order PDFs. Very simple. So if you are able to find first order PDFs, from first order PDFs, you can find first order CDFs also. From first order PDFs, can you find second order PDF? That is not possible, because first order PDFs are there means individual information of x and individual information of y is there. But if you want combined information, the joint information, you should also know the relation between them. That information is not available in individual PDFs. So if you know individual PDFs, from this you can't construct the second order PDF. But only one special case is there where you can construct that. If x and y are independent, that is when you can do that. If x comma y are independent random variables, then fxy of x comma y can be written as fx of x into fy of y, and capital fxy of x comma y also can be written as capital Fx of x into capital Fy of y. One important scenario for us is always the independent relation between random variables. Things will become easy when relation between random variables is independent. Okay, I'm moving forward. So I'm talking about one important scenario here. Function of a random variable. So let's say x is a random variable. For x, PDF is given. If fx of x is given, which means PDF of x is given, and somebody told us the relation between x and y, like something like y equal to 2x plus 3, x square, x cube, something like that, cos x, sin x. So some new random variable y is formed using x. Now if you know the PDF of x, So how to find the PDF of y? So this is the easiest way to find it. I'm not talking about general case, okay? So there are some tricky questions also possible. So I'm not discussing that those models here. Generally questions are not given in the previous set papers for the other tricky models that I'm talking about. So this PDF, this is the relation if y equal to g of x is a monotonic function. Monotonic means continuously increasing or continuously decreasing functions, or invertible functions you can say. So for monotonic functions, the answer is very simple. If you want to find the PDF of y, this is the relation. Okay, for non-monotonic functions, I'm avoiding it in this revision class. Okay, right. I'm going to talk about a special case, which is the case which will be focused in the exams also generally, because this is the case where you can observe things and easily tell the answers. So I'm talking about some linear relation, some kind of linear relation, y equal to ax plus b kind of relation, y equal to ax or ax plus b or ax plus b. So if you plot the relation between y and x, it should be some kind of straight line. If that is the kind of relation between two random variables, then things become very easy to analyze. So that scenario I'm talking about here. So here, let us use the same formula here. Fy of y is equal to fx of x into modulus of dx by dy. Yes, this is what means why I have written in a simple way like this, because it's easy to remember in this format. But there is a lot of meaning here. You have to understand carefully. Here you want a function of y. If you have only x, how will you get a function of y? So convert x into y, because you know the relation between x and y. Convert x into y. How do you convert x into y? Since it is a if it is a monotonic function, you can write, if it is a monotonic function, x can be written as g inverse of y, because it will have an inverse. And in this case, what is the inverse? X, can you express it in terms of y? That itself is the inverse. Y minus b by a. Y minus b by a is the inverse function. So in place of x, just substitute the function of y, fx of, in place of x, substitute with y. It is y minus b divided by a into d by dy of, in place of x, substitute y minus b by a, modulus. Why modulus? Because since we are talking about PDF probabilities, there should never be negative value. Differentiation might produce a negative value. That's why to avoid that, we are putting a modulus here, which is fx of y minus b by a into, what is the differentiation of y minus b by a with respect to y? It is 1 divided by a. Say this, we got some beautiful relation here. There is a lot to observe here. There is a lot to observe. If the relation between y and x is some kind of a straight line kind of relation, linear or incrementally linear kind of relation, then what is the relation between PDF of y and PDF of x? So this function and this function, if you see the relation, fx of x, this is, can I say, shifted and scaled? Can I say that? Here shifting is being done and scaling is also being done, correct? Shifting and scaling, right? So when you shift it, will the shape, name of the shape change? If it is Gaussian, if you shift it, it will still be Gaussian, no? If it is uniform, if you shift it, it will still be uniform, right? So if it is Gaussian, if you scale it, if you compress it or expand it, it will still be Gaussian. If it is uniform PDF, if you compress it or expand it, will still be uniform, right? Shifting and the scaling will not change the name of the shape. The name of the shape of the PDF will not change if the relation between the random variables is this kind of relation. If you multiply with a constant or add with a constant or multiply and add with a constant, then the name of the shape of the PDF will not change. If the name of the shape of the PDF does not change, then things will become very easy to answer the questions. Okay, things will become very easy, right? If in this kind of relation, if x is Gaussian, y also will be Gaussian. Okay, because of addition of a constant, mean will change, variance might change. Okay, mean, variance, mean square values might change. Because of multiplication with constant, also mean variance and the mean square value might change, but their shape name will not change, correct? We have discussed that. It might get compressed, it might get shifted, but name of the shape, if it is Gaussian, Gaussian only. It might be expanded and shifted, right? So there is a important point that we have learned here. I'm talking only one special case here. In this case only, the problems can be very easily done. In other cases, we have to put little bit of effort mathematically. Okay, so I'll ask you some questions here, okay, so that it will become clear for you. If x is a uniform random variable, then and uniform random variable taking values 2 to 6 and y equal to 4x plus 7, then what can you tell about y? What can you tell about y? I'll ask you one more question also to get more clarity. If x is Gaussian random variable means it will have mean and variance, right? So let me give that mean and variance as 2 and 4. Anyone can answer me this? Can you tell me the name of the shape of the PDF of y? X has a PDF whose name is uniform PDF. Thank you, Venkatram. Good that you have followed them. You have a lot of patience and you have a lot of interest also in learning, definitely. Right, so name of the shape will not change if there is a relation like this, linear relation or incrementally linear relation like this. Correct? So if x is uniform, y also will be uniform. Correct? Because relation is in this form, y equal to x plus b kind of form. Here also, if x is Gaussian, then y also will be Gaussian because the relation is in the form of ax plus b. The name of the shape will not change, but their mean, variance, mean square values might change. Okay, so if you can figure out, so now since this is uniform, if y is uniform, what are the other important things? The values taken by y. If you can know that, that is sufficient. So if x takes, what is the first value of x that is possible? X takes starting value of x is 2, right? If x is 2, then what will be y? If x is 2, 4 2s are 8 plus 7 is 15. When x takes 2, y takes 15. If x takes 6, the highest value of x possible is 6. And if x takes 6, 4 6 are 24 plus 7 is 31. Correct? So y, range of y values possible is 15 to 31. Y is uniform and takes values 15 to 31. That is sufficient or not? If they ask mean, variance, anything, we can say that, no? If you know the range of values, you can plot the shape of the PDF also. It is uniform from 15 to 31. We have formulas to find mean, variance and other things. So midpoint of 15 and 31 will give us the midpoint of 15 and 31 will give us the mean value. And variance, if you want, remember the formula b minus a whole square by 12. That formula you can use. Mean square value, there is a formula a square plus ab plus b square by 3. That formula you can use. If you don't remember the formulas, you can go with the regular procedure. You know the formula for expectation of x square, integration of x square into fx of x dx. Yes, you can do that also. But I've suggested you to remember mean square value, variance formulas for uniform PDF and exponential PDF. For Gaussian, there is nothing to remember. There is no need of any formula. Okay, because when Gaussian PDF is given, we can clearly see the mean value. If equation is given, mean and variance are always visible. Okay, next one. We know that y is Gaussian. For a Gaussian, if you can tell the mean and variance, the story is done. If x is Gaussian and the relation is like this, once you see the relation is like this, we know the name of the shape is Gaussian. If it is Gaussian PDF, if you know the mean and variance, that story is done. You can plot it, you can write the equation, anything is possible. You can do anything. So finding the mean and variance is important for us. So from this relation, can we find the mean and variance? Y bar is equal to 2 times x bar plus 5, correct? What is the mean value here? 2. If mean is 2, 2 to the 4 plus 5 is 9, right? Very good. How about variance? I think you can say the variance very easily. Sigma y square. Because of addition of constant, variance will not change. Because of multiplication with constant, variance changes by constant square times. So it becomes 2 square is 4 times a sigma x square. No contribution to variance because of constant, because of addition of constant. Okay. So I hope you understood. Now this will be variance earlier was 4. 4 into 4 is 16 is the variance now for a random variable y. So it becomes mean value is 9 and variance is 16. I hope you got the same answers. So let me move forward. So we'll discuss about I'll discuss this formula once so that I can discuss the models of problems on x plus y, x minus y, maximum of xy and minimum of xy, and we'll give you some interesting questions here. A lot of questions I've framed here. Okay. So here earlier we've talked about function of one random variable, right? Similarly, let's say two random variables are there, x and y, and their joint PDF fxy of x comma y is given. We know this one, and they have formed two functions of two random variables, z and w are two new random variables formed using x and y. Like something like this is like x square plus y square, or x plus y, or this is x square minus y square, or x minus y, that kind of some function of x and y. So we have formed two new random variables, and those random variables also will have a joint density function, right? That joint density function we can find using this relation. With the help of this relation, we can find the joint density function of new random variables formed using the PDF of old random variables. Okay, so to make the formula look easy, I have written in this format, but here finally you want in terms of z and w. So here also you should express it in terms of z and w. So replace x and y here, and here replace x and y in terms of z and w, because finally we want it in terms of z and w. So express x and y in terms of z and w, because you have a relation between zxy, wxy. So try to solve or express x and y in terms of z and w, and substitute here and here, and then you can do the differentiation, and then you can do, this is det operation, and that I'm calling it as j of x comma y. You can take any notation that you want, but the formula here is important. It's a simple formula. Since this is revision class, I'm not going to get into very details of it. I can't take too many examples. Okay, this is the relation which you can use for two functions of two random variables, right? I'm going to use that here. So z equal to x plus y. We don't know one function of two random variables. One function of two random variables. Only if there is only one function of two random variables, there is no formula for us. So that's why what I'll do is, so they have given us z equal to x plus y. z equal to x plus y. There is no relation for w, there is no random variable w they have given us, but we will assume something. We'll take w, another random variable also, so that we can use the formula which is shown in the previous slide. So what we can take here, we can take it as x minus y, but just to make things simpler, let me take it as just y. Why am I taking that way? Because if you know fzw of z comma w, you can find first order PDFs. No? You can find the PDF of z, you can find the PDF of w just by integrating this. So if you can get the second order density function, you can find the first order density functions using the relationships that we have discussed previously. These relationships, you can use these relationships. From second order PDF, you can find the first order PDFs. Okay. Since we have a formula for two functions of two random variables, we want to use that. So that's why, though they have not given second random variable, I have taken it. So now if you want to find it, fzw of z comma w is equal to, I'm just using the formula here. Try to understand how I'm gonna use that formula. G of x comma y and j of x comma y, the formula, I'll reiterate the formula once. Dou x by dou z, dou x by dou w, and here there is a det for this because we want only positive values here. Dou y by dou z. I'm just rewriting the formula what we have written in the previous page so that we can use that formula. Now, okay, so we want everything converted to x and y, replace it in terms of z and w. So from this relation, can we express x and y in terms of z and w? X can be written as z minus y, but we want to write x in terms of z and w, not z and y. But y and w are same, so we can write as z minus w. And y also we want to express it in terms of z and w. Y is same as w. So replace things. So it is fxy of x comma y. In place of x, I'm replacing z minus w so that this function gets converted in terms of z and w. And y, I'm replacing it with the w into what is j modulus of j of x comma y. Let's see that here. What is differentiation of x? When x is expressed in terms of z and w, z minus w is x and y is w. Let's differentiate this z minus w, which is same as x, with respect to z. When you differentiate this with respect to z, partially differentiate with respect to z, it becomes 1 minus 0. And when you partially differentiate this with respect to w, it becomes minus 1. And y, let us differentiate with respect to z, it becomes 0 and it becomes 1 here. So if you take the det, it becomes 1. So that is the relation between fzw of z comma w and fxy of x comma y. So if you know the joint density function of x or xy, from that you can get the joint density function of z and w. But we are not interested in joint density function of z and w because there is no such random variable w given in the problem. So let us eliminate this w by using the relations that we know between first order density functions and second order density functions. So what do we want? We want only fz of z. We want only fz of z. So how do you find it? Just integrate this function with respect to w, we'll get it. fzw of z comma w dz. Sorry, z we want, so let us integrate with respect to w, which is, we know what is this function we have found it just now, fxy of z minus w comma w. We want to eliminate w, so let us integrate with respect to w. Okay, fine. So this is the relation. So this is how we can find fz of z. So basically limits are from minus infinity to plus infinity, but if they have given you what values w y will take, same values w also will take, you can put those values here. If no values are given, you can take it as minus infinity to plus infinity. Fine, this is the general relation. This is the general relation. Okay. But the most important result happens if x and y are independent. If x and y are independent random variables, x and y are independent random variables, then what happens is fxy of x comma y can be written as fxy of x comma y. Sorry, my mistake. Joint PDF can be written as product of individual PDFs. Product of individual PDFs. So here we are having the joint density function where some replacements happened. Z minus W comma W. Same function in the whatever is in the top. Same thing I'm replicating here. In place of x, I'm putting Z minus W. Same thing you do on both sides. And in place of y, I'm putting W. Fy of W. Okay. So if x and y are independent, if x and y no independent relation is given, then you can stop at this place. But if independent relation is given, you can write it as fz of z is equal to integration of this. I can write it as fx of z minus w into fy of w dw, and you can take the limits from minus infinity to plus infinity. There is nothing wrong in taking limits from minus infinity to plus infinity. And if you look at this relation, is it not looking like convolution? If you remember convolution relation, it is looking exactly like convolution relation. Fx function and fy function, the convolution between those two, it is looking like that. This formula is looking like that. But what is the final variable z? So that's why I'm taking the same variable here also. Fx of z convolution with fy of z. Don't look at the notations and get confused. The PDF of x and PDF of y, there is some shape for PDF of x, there is some shape for PDF of y. Just convolve them in whatever procedure you know. Just convolve them. The result is the shape of the PDF of z. As simple as that. If you know how to do convolution in any procedure, do the convolution. That's it. X PDF and Y PDF, just convolve. The resultant shape is the PDF of z. Convolution of two PDFs is giving the another PDF only if the relation is z equal to x plus y and if x and y are independent. If x and y are not independent, this convolution relation is not valid. This convolution relation is valid only if x and y are independent and z is given as x plus y. Okay, I hope you're following. Okay. Similarly, I'll take other cases also. If z equal to x minus y, so let me write what result we have found in the previous page. If z equal to x plus y, fz of z can be written as fx of z convolution with fy of z. Just convolution, simple convolution. Similarly, if z equal to x minus y, then what? Fz of z is equal to, if z is given as x minus y, then it can be written as fx of z convolution with, just look at it as x plus of minus y, x plus of minus y. Okay. So it is looking like exactly like this. In place of y, we are having minus y. In place of y, we are having minus y. So what is the PDF of minus y? What is the PDF of minus y? Let me say this one. If y equal to minus x, then what is the relation between the PDFs? Fy of y is equal to fx of minus y, correct? You can take any the formulas that we have discussed previously. I'll show you. So here, this one, you can take this formula. If y equal to minus x, if y equal to minus x, x equal to minus y, you can substitute x with minus y. Differentiation of minus y is minus 1. If you apply modulus, it will be plus 1. Replace x with minus y. Fy of y equal to fx of minus y. You can take this formula, you can use this formula to find PDFs quickly when there is relation between two random variables. Okay. Similarly, could you tell me y equal to 2x? Could you tell me what is the PDF? Fy of y is equal to, if you want, I can write the formula again. So it is dx by dy. So this implies Fy of y is equal to fx of, let's replace everything in terms of y. X can be written as y by 2 into differentiation of x. X equal to y by 2, differentiation will give you 1 by 2. Like this, if any really linear relation is given, it's very easy to find the relation between the PDFs. So what do we want? We want the PDF of minus y, right? We want the PDF of minus y. So PDF of minus y means the same PDF, replace, they have a minus sign inside. Or else, commonsensical way is, if you have a random variable which takes values from minus 3 to 6, then if you apply minus into that random variable, it takes values from minus 6 to 3. The probabilities of negative values, the negative values will become positive values will become negative values. Similarly, probabilities also will be assigned in a similar manner. So which means it is nothing but the PDF will be inverted with respect to y-axis. Similarly, if z equal to, could you tell me this? 2x plus y, fz of z is equal to, very simple. So look at this as x dash plus y, something like that. So it will be fx dash x dash PDF and y PDF, x dash PDF and y PDF. So what is x dash PDF? X dash is what? 2x. If x dash is 2x, then PDF of x dash is, inside it will be y by 2, outside it will be half. So it will be fx of x by 2 into outside it is half. This relation I'm using. And fy of y as it is. Similarly, I'll ask you one more. Let's see. 4x plus 3y. How about that? If you can tell this, you have understood this very, very clearly. How about the PDF of z? So 4x, look at it as x dash, and 3y, you will look at it as y dash. So see, if you take y as 4x, so these relations and these relations are not same, okay? Just for examples I'm taking. If the relation is 4x, instead of x dash we are having 4x. I'll take it as like that only. X dash is 4x. This I'm looking at as x dash, and this I'm looking at as y dash. X dash is 4x. Now I'm talking about PDF of x dash. Fx dash of x dash is equal to fx of x. In place of x, how do we write it? We can write as x dash by 4, and dx by dy. In place of y, we are having the x dash, dx by dx dash. So x we can write as x dash by 4. Differentiate x with the dx dash, which is 1 by 4. Same procedure you can apply. Similarly, 3y also I'll do. Y dash is equal to 3y. If you are confused, I'll write the formula and I'll do it now. Fy dash, if you are confused here, I'll do it here. For this case, in a regular procedure, Fy dash of y dash is equal to fx of x into modulus of dx by dy. Okay, but here x is not there, only y is there, and y dash are there, so it will become y here. So formulas also have to change according to the variables. Here no x and y, here only y and y dash. So in place of y and in place of y, we are having y dash, dy by dy dash. See this? First I have written this formula only, Since they in place of x we are having y, I'm replacing wherever x is there, I'm replacing it with y. So it is equal to, what do we replace y with? Y we can replace with y dash by 3. Why? Because finally we want it as a function of y dash, and differentiation of y with respect to y dash. If you want to differentiate y with respect to y dash, express y in terms of y dash, which is y dash by 3. Differentiation is 1 by 3. So shall we write the convolution now? So it's like, it is, look, just always whenever they give you this kind of relation, addition kind of relation, look at it as simple relation like x plus y kind of relation. If it is not simply x plus y, whatever is in place of x, some 4x, look at it as x dash. In place of y, some other thing, look at it as y dash. Okay, if it is x dash plus y dash, take the PDF of x dash, find the PDF of x dash, find the PDF of y dash, and just do convolution. Find the PDF of x dash individually, find the PDF of y dash individually, and then do convolution. It will be simple, right? If you want to write it, so you don't need to write mathematically in this format. You can just find PDF of 4x from this relation. You can find the PDF of 4x, and you can find the PDF of 3y using this relation. Once you get these two PDFs, just do convolution in any format that you know. Right, so f z of z is equal to, what is the PDF of 4x? We just now found it. PDF of 4x is fx of x dash by 4. We don't have a variable called x dash, we have only z. So let me write as z by 4 into 1 by 4. And what is the PDF of 3y? We got it here. 3y PDF is like this. Since the final variable is z, I'm not going to write y dash, I'm going to write z here. So any problem based on this relation, x plus y, x minus y, 2x plus 3y, 4x plus 7y, any kind of relation, any kind of random variables are multiplied with constants, any constants, and then added or subtracted, we can do the problem very easily, provided you know convolution very well. By using some procedure, if you are able to do convolution quickly, then yes, you can do these problems very easily. And don't think that convolution is, definitely convolution takes time, but generally they'll give problems in such a manner that they'll give the shape of the PDFs in such a manner that convolution becomes easy. Mostly they will involve only rectangle kind of signals or maximum triangle kind of signals. Triangle also involved means convolution will become difficult. So mostly they'll involve rectangles or simpler PDFs, so that convolution becomes easy. Okay. So I've discussed how to solve problems of this model. Two random variables, two independent random variables are given, their individual PDFs are given, and if they are forming a new random variable z in this manner, in any of these forms, how to solve the question using convolution relation, you can solve it. Right, one more model of problem, this model and one more model. So let me discuss the basic concept regarding these two models also, and then we'll do problems based on all these models. Okay, I've given some interesting questions, so I framed these questions today only. I want to give you something new, so that's why I've put in some effort today to frame some new questions. So z equal to maximum of x comma y. So f z of z is what we want, which means we are interested in f z of z. What is the meaning of it? We are interested in the accumulated probability till z. The meaning of this is probability of z less than or equal to small z. If z naught is here, it will be z naught here. It means okay, what is given about z? The information given about z is, it is given as maximum of x comma y less than or equal to z. Try to understand the next step correctly. It's a very crucial step. From this step to the next step, if you can understand, everything else is simple. So if you want a maximum of x comma y less than z, for example, x and y are two random variables. They can take any values. Okay, maximum of x comma y, instead of z I'm taking some value. Okay, so let's say I'm taking 3, just for understanding sake. Instead of z I'm taking 3, just to understand. If you want maximum of x and y, maximum of both of them, if you want it to be less than 3, then what should happen to x individually and y individually so that this will happen? What should happen? If x is also less than or equal to 3 and y is also less than or equal to 3, definitely maximum of x comma y also will be less than or equal to 3, right? Correct? This will happen or not? Maximum of x comma y less than or equal to 3 will happen if x is less than or equal to 3 and y is also less than or equal to 3. X and y are random. They need not be less than 3 or y less than 3. But if that happens, then only this happens. This happens, then this will happen. Right? This is correct. Now let me take the wrong case also, then you'll understand. X greater than 3. If x is greater than 3, if x is greater than 3, then maximum of a value which is greater than 3 will be 3 greater than 3 only. No, it will not satisfy this relation, right? If x is greater than 3 and y also greater than 3, then this will not happen. This relation, if this is happening, if any of this is happening, this will not happen. So this can't be written in this format because these two are not the same things, but these two are same. And one more thing, x greater than 3 and y less than or equal to 3. If x is greater than 3 value, y is a value which is less than 3, then maximum will definitely be greater than 3 only. So this also is not same as this. Similarly, x less than 3 and y greater than 3. If y is greater than 3, then maximum if you find it will be greater than 3 only. This also is not same as this. So this is exactly same as this. So if you want maximum of x comma y less than or equal to 3, then x should be less than or equal to 3 and y also should be less than or equal to 3. For example, I have taken 3 here, but here what we want is z. So if you want maximum of x comma y less than or equal to z, then x should be less than or equal to z and intersection. Intersection we generally write it as comma. When there is a comma, you can understand it as intersection. So y less than or equal to small z. Okay. Wonderful, we're done. This step is sufficient for us. So this is the relationship fz of z. We got it. But the only important case for us happens if x and y are independent. If x comma y are independent, then what happens? If x and y are independent, then what we can say is fz of z is equal to, or probability of maximum of x comma y, probability of maximum of x comma y less than or equal to small z. How do we write it? We know we can write it like this, but when they are independent, x and y are independent means their joint probability can be written as multiplication of individual probability. When x and y are independent, any event formed on x and any event formed on y will also be independent. So we can write as x less than or equal to z multiplied with probability of y less than or equal to z. Okay. Yes. So this is the relationship which is valid if x and y are independent. So probability of maximum of x comma y less than or equal to z can be written as probability of x less than or equal to z and into multiplied with probability of y less than or equal to z. Why I have written like this? Because x and y are independent. When x and y are independent, joint probability can be written as multiplication of individual probability. This is one event A and this is one event B. Since x and y are independent, any event formed on A and any event formed on B will be independent. So P of this is looking like something like P of A intersection B, which can be written as P of A into P of B. Okay, I hope it is clear till this point. So whenever you see probability of maximum of x comma y kind of relation less than or equal to some value z, then you can just rewrite it like this. Then it will become very easy to solve the problem. So this is the concept for solving this kind of problems, maximum of x comma y. When they give you PDF of x and y, and if they say that they are independent and they form new random variable z as maximum of x comma y, This is the concept that you can use. If you forgot this, definitely you can analyze from the starting also. Generally, once you understand, you will not forget if you understand clearly. Right, one more relation. In a similar manner, let us analyze probability of, sorry, so we want FW, capital FW of W. First, let us write the meaning of this. Probability of capital W, because W is random variable here, less than or equal to small w. That is the meaning. What is given about W? Minimum of x comma y is the relation that is given. Let us write what is given about W. Minimum of x comma y less than or equal to small w. Why am I replacing here? Because this is a random variable. This is particular value of random variable. This is like some constant value that we are interested in. So FW of 4 if you're talking about, this is 4, this is 4, this is random variable. Probability that random variable is less than or equal to 4. So this is the constant where we can't substitute the relation that is given. Okay. Now when will minimum of x comma y less than or equal to w? When will this happen? Minimum of both of them should be less than w. It happens minimum of x comma y. Try to analyze in the same manner that we have analyzed previously. Minimum of x comma y less than 3. I'm taking a value, particular value, just to understand clearly. If x is less than 3 and y also less than 3, will this happen? If both of them are less than 3, then definitely minimum also will be less than 3, no? Correct? And if x is less than or equal to 3 and y greater than 3, then what happens? If one of them is less than 3, here one of them is less than 3, then minimum also will be less than 3, no? If x is greater than 3 and y is less than 3, then also this will happen. So in all these three cases, this relation is satisfied. Only there is one case which is x greater than 3 and y also greater than 3. If both of them are greater than 3, then the minimum if you find that also will be greater than 3. Only in this case it is not satisfied. So all these three cases we are interested, which is minimum of x comma y less than w means it is first case is x less than or equal to 3 comma y less than or equal to 3 case, or you can write it as plus. So probability that this happens means you should talk about probability of this, and probability of this. Now all these three events, this event happens. Or if you take this as A and this is B and this is C event, A and B and C, all these three events together, it will give us this event. This event is equal to A union B union C, you can say. Okay, so combination of A, B and C. So if you want the probability of this event, you should add up the probabilities of these three. So probability of first event and probability of second event is P of x less than or equal to 3 comma y greater than 3 plus P of x greater than 3 comma y less than or equal to 3. Okay. Or we can also write it as we don't want this event, right? Among these four events, if you remove this event, then these three events will be responsible for this event. So we want the probability of these three events. You can find the probability of these three events and add them, or you can find the probability of this and you can subtract from 1 to get the probability of these three events. And we can write it as 1 minus P of x greater than 3 comma y greater than 3. That way also we can understand. Both ways are fine. Okay, right. So let us simplify this relation. FW of W is equal to, we can write it as 1 minus So you can write it in this manner, or there is another way actually. There is another way. There is more easier way actually. You can write same thing. So in this case also, independent relation is what is important for us. The problems will be framed on independent relation only, not on normal relation between random variables. Independent relation is what is important for us. Okay, so let us try to understand it in another way. If one of the random variables x and y is less than 3, if one of them is less than 3, then minimum is decided by the minimum of both of them, right? If one of them is less than 3, then definitely minimum also will be less than 3, right? So if you want probability of minimum of x comma y to be less than 3, you can understand the probability that x is less than or equal to 3. I mean, here we're not interested in 3 here actually, we are interested in w, right? For example, we have taken 3. X is less than or equal to w will give us the probability. If you know the probability that x is less than or equal to w, it will also add up to the probability of minimum of x comma less than w, plus when y is also less than or equal to w, that also will result in minimum of x comma y less than 3. If one of x and y, if one of them is less than w, then minimum of them also will be less than w. But in this case, there is a case, in this case there is a common case where both are less than w, so that probability is being added twice, so that's why we are subtracting that case here. P of x less than w comma y less than or equal to w. So the probability here is there included in here and here, that's why we are subtracting once. So this way is also right. This whatever we have written is here also is right. Here this is also right. Whichever you are comfortable, you can do it. So let us talk about only the independent case. If x and y are independent, if x and y are independent, if x and y are independent, then fw of w is equal to this one. I'm just copying it as it is. P of x less than or equal to w plus P of y less than or equal to w minus this joint probability can be written as multiplication of individual probabilities. Okay, so what is the meaning of this? Probability that minimum of x comma y less than or equal to w, when if you want the probability of what probability this happens, then find the probability with which x happens to be less than w, find the probability with which y happens to be less than w, and then find, and those two probabilities you just multiply them again. Very simple. Okay, I hope you have understood. I've given the basic concept regarding maximum of x comma y and minimum of x comma y. Let's do a problem based on that. Okay, once you understand the concept, solving questions is not a big deal. Travel engineer, good evening. I'm doing good. Right, so this is the question. Try to understand the question carefully and then solve it. Right, so another 10 more minutes to wind up the class. I think we should be able to do this, solve this question within the next 10 minutes. So you can do it along with me. So if you are able to do it the same speed as me, it means your understanding is amazing. Fine, the first question, how about x plus y? So whenever they give you a problem like this, so Don't get confused. X plus y. How did we discuss? We have taken it as z equal to x plus y. Don't expect always they should give you that z equal to x plus y. What is the probability that z less than 2 or z greater than 2 or PDF of z? Don't expect the questions to be in the same manner as we have discussed the concept. Whatever manner they ask the questions, try to frame it in the way that you have learnt it. Right. So whenever they say x plus y or x minus y or 2x plus 3y, take this part as z. Take this part as z. Okay. So they are talking about probability of z equal to 0. Okay, probability of z equal to 0. What is the probability of so we are talking about continuous random variable only, no? What is the probability at a particular, what is the probability of taking a particular value for a continuous random variable? Generally it will be 0, except only one case when there is an impulse. So here there is no chance of impulse because the PDFs are given in such a manner. Like, let me explain the question a little bit more. IID means what? IID, whenever they use this word IID, it means independent. First I means independent, second I means identical. Identical, which means x and y are having same PDFs. Identical means identical PDFs, identical moments, etc. Identical distribution. Expansion for IID is independent, identically distributed. Independent, identically distributed. So x and y are having same PDF and x and y are having an independent relation. Only in independent relation case only these problems will be easy. If it is non-independent, then it will take a lot of time to solve the question, but we can solve it. So x is taking values from -1 to 3 with equal probability. They are giving us the PDF of x. They are saying that it is having a uniform PDF -1 to 3. So equal probability. When they say equal probability, it means uniform PDF. X PDF they have given. Since x and y are having identical distributions because they are saying that it is IID. Y PDF also is same. Y PDF also is exactly same. Height will be 1 by 4 because it is PDF area should be 1. Now tell me, x plus y. How do you find the PDF of x plus y? If z equal to x plus y, PDF of z is convolution of PDF of x and y. Fz of z. I'm not gonna write all the formulas now. I'm just gonna do the problem directly. So it is fx of z convolution with fy of z. Don't bother the notations. The notations are not really important. You know the PDF of x, you know the PDF of y, which is also same as this. You can do convolution. What is the convolution of two rectangles of same width? It is triangle. So what is the lower limit? -1 is the lower limit for this. -1 is the lower limit for this. -1 plus -1 is -2. I'm just talking about convolution here, nothing more. And highest point will be 3 here. 3 is the highest point here for this PDF, and 3 is the highest point for this PDF also. 3 plus 3 is 6. So this is how it looks like. So PDF of Z we know. Right. So what is the height? Height is what is the midpoint here? Midpoint is 2. Midpoint of these 2 points. And what is the height? Height is 4. It should be 1 by 4. Then only the area will be 1. So we got the PDF of x plus y. Any number of questions framed on x plus y we can do now. I have asked only two questions only, but any question asked on x plus y. If you want to find the answer for this kind of probabilities, you just need to find the PDF of x plus y. Assume z as x plus y and then find the PDF. Then you can do any question based on x plus y. X plus y greater than 2, less than 3, less than 4. Anything we can find. Once you find this, you just need to find the area according to the given question. So what is the probability of x plus y equal to 0? It means they're talking about probability of x plus y taking 0 minus to 0 plus values. So 0 minus to 0 plus values. What is 0 minus to 0 plus values? What is the area? What is this area? The area is 0, no? For a continuous random variable, probability at a particular point is generally 0 unless there is an impulse, right? So what is the probability that x plus y is less than 2? The x plus y PDF we are having here, we want it to be less than 2. You can see that this is symmetrical PDF. And before 2, half of the area is there. After 2, half of the area is there. We know the total area is 1. So the answer should be half. If you want, you can calculate also this area. Half into base into height. Base is 4. Height is 1 by 4. Half into 4 into 1 by 4 is half. Generally, they'll give us questions where we can guess the answer easily. Here they're asking us just before the mean value. Mean value here is 2. You can recognize because it is symmetrical PDF. How about x minus y? If you want to find x minus y greater than 0, then you should know the PDF of x minus y. If you say w equal to x minus y, can you find the PDF of x minus y? PDF of x plus PDF of minus y. PDF of x is this, PDF of minus y. PDF of y is this, PDF of minus y will be from minus 3 to plus 1. Minus 3 to plus 1. Two rectangles of equal width, if you convolve, it will be triangle. So x PDF will be something like this. Y PDF, we know exactly same as this, but we want minus y PDF. We want minus y PDF. So for minus y PDF, how it will look like? Minus y means just invert the values, invert the PDF. It will be something like this. Plus 1 minus. This is how it looks like. So just no, there is no need of there is no, you don't need to take this notation seriously. You can take any notation. Notations are not really important here. Convolution is important here. So since we want we are interested in x minus y random variable x minus y, you have to convolve PDF of x with PDF of minus y. PDF of x we know, PDF of minus y I have plotted. So let us convolve these two. If you know how to do convolution, it's an easy thing. So minus 3 plus minus 1 is the lower limit, which is minus 4. 3 plus 1 is 4. 4 is the upper limit. So convolution of two rectangles of equal width will result in triangle. Okay. So if you want height is 1 by 4. Height should be 1 by 4. Then only the area will be 1. So this is the PDF of x minus y. Once you have PDF of x minus y, you can do any problem based on x minus y. So what is the probability that x minus y is greater than 0? Half of the area is present from 0 to infinity. So it should be half. Okay. Wonderful. Now next step, 2x plus 3y they want. So we want PDF of 2x. Can anyone guess what is the PDF of 2x? It's easy, man. Come on. 2x. X takes values from minus 1 to 3. 2x will take values from minus 2 to plus 6. No. X is taking value of minus 1 means 2x will take a value of minus 2. And if x is taking a value of 3, 2x will take a value of 6. Common sense. Nothing more required. Minus 2 to plus 6. 2x PDF I have plotted. Next step. What else we want? 3y PDF. So 3y PDF if you want 3y. Y PDF is also same as this. If y takes value minus 1, 3y takes minus 3. And if y takes value plus 3, 3y takes plus 9. Right? So if you convolve these two, 2x and 3y, if you convolve these two, then it will be some kind of trapezium. When you convert two unequal rectangles, then it will result in a trapezium, right? So how about the mean value here? For this, the mean value is plus 2, right? And for this, the mean value is plus 3, correct? So what is the mean value of convolved thing? When two random variables are added, mean values are also added. So expectation of 2x plus 3y is 2 into expectation of x plus 3 into expectation of y, correct? So mean value is 5 here. So when you convolve these two, it will be trapezium, some kind of trapezium, right? So for the trapezium, mean value, trapezium is it symmetrical PDF or not? Yes, it is symmetrical PDF. For symmetrical PDF, the mean value is 5 means it is symmetrical with respect to 5. So which means half of the area is above after 5 and half of the area is below 5. So the question asked is based on simple observation only. If you don't plot the PDF of also, without plotting the PDF itself, if you have recognized that the mean is 5, half of the area is present after 5 and half of the area is present before 5. If you have not recognized that, that's fine. You plot the trapezium, then you'll understand what is this area. So from 5 to infinity, find the area. That will result in half. Okay, if you're not able to do it faster, just go with your own speed, no problem. Okay, wonderful. Next, probability of x square less than 4. X square PDF we don't have, okay, we have only x PDF. So try to convert this x square into x format. So if you want x square to be less than 4, then x should be between minus 2 to plus 2, correct? When x takes values from minus 2 to plus 2, in this range, if you square them, it will definitely, the squared values will be definitely be less than 4. So we're talking about this. So if you look at this one, it is looking like CDF of means probability of x naught less than x1. So can we write as P of x less than or equal less than 2? less than or equal to, it should not matter for continuous PDFs. Equal to is there or not, it should not change the result generally unless impulses are present. Minus p of x less than minus 2. Okay, so p of x, we know the PDF of x here, it is clear, very clear here. So x less than 2, before 2 what is the probability? Sorry, this is not 2, this is 2. Before 2 what is the area? This total area. Width is 3 units, height is 1 by 4, 3 by 4 is the area. Minus probability of x less than minus 2. Probability of x less than minus 2 is 0, which is 3 by 4. Or else we can find the area from minus 2 to plus 2. Minus 2 to plus 2 also will give us the same answer, which is 3 by 4. How about mod x greater than 1? If you want mod x to be greater than 1, it should be, can we write as 1 minus p of mod x less than 1? You can write it 1 minus p of mod x should be less than 1, means it should be, x should be between minus 1 and plus 1, correct? So how about, if you want to find the probability of x taking values from minus 1 to plus 1, you just find the area of the PDF from minus 1 to plus 1. From minus 1 to plus 1, what is the area? Width is 2 units, height is 1 by 4. Width is 2 units, height is 1 by 4, which is 2 by 4, which is half. Probability of y cube less than 8. If you want y cube to be less than 8, definitely y should be less than 2. If y is less than 2, y cube will be less than 8. For all values of y less than 2, y cube will be less than 8. So you just need to find out probability of y taking values less than 2, which means in y PDF, x and y have same PDFs. In y PDF, find the probability or area from minus infinity to 2, which is again 3 by 4. Okay. Next, come on, next one. So you want maximum of x comma y to be less than or equal to 2. I have discussed the concept regarding this. Whenever you see maximum of x comma y to be less than 2, this happens only if x is less than or equal to 2, comma y is less than or equal to 2. If both of them are less than 2, then only maximum of x comma will be less than 2. Okay. Similarly, minimum will happen if one of them is less than 1. If one of them is less than 1, then that is sufficient for us. Okay. If x is less than or equal to 1 and or y is also less than or equal to 1, and let us subtract the common case, which is x less than or equal to 1, y less than or equal to 1. We have discussed this in the previous slides. Okay. Next, in these kind of models, what should we do? It is looking like p of x naught less than x1, right? So what should we do in these cases? So let us write it as probability that x is less than or equal to x1 minus p of x is less than or equal to x naught. So whenever you see a range like this, you just write it in this manner. We have discussed this in the previous class also. So can we write it as p of maximum of x comma y less than or equal to 1 minus p of maximum of x comma y less than or equal to 0. Okay. So since we're talking about continuous random variables, equal to is there or not, don't worry about that much. So this is the basic idea. Once you look at this one, if you can convert into this format, then the answer is same as this one. You can convert it as this is equal to. So if you want maximum of x comma y to be less than or equal to 1, x should be less than or equal to 1 and y also should be less than or equal to 1 minus p of x. If you want maximum x comma y to be less than or equal to 0, x should be less than or equal to 0, comma y also should be less than or equal to 0. Both should happen. Then only maximum will be less than 0. Next, how about this one? We have not discussed about maximum of x comma y greater than something. We can understand that also in a similar manner, but it's easy to convert in this format now. If you want a random variable to be greater than some value, we can write as 1 minus p of the same random variable less than that value. We can write this, we can rewrite this in this format. Now it is converted into our original problem. So if you want maximum of x comma y to be less than 1.5, what should happen? X should be less than 1.5 and y also should be less than 1.5. Since we're talking about independent random variables, this joint probability can be written as multiplication of individual probabilities. Next, here also, this also we can write as 1 minus p of minimum of x comma y less than or equal to 0.5. So if you want minimum of x comma y to be less than 0.5, x should be less than or equal to 0.5, y also should be less than 0.5, and subtract both being less than 0.5. Okay. So this intersection case, it says very easy. Find the individual probabilities, probability of x less than 1, probability of y less than 1, and just multiply them. That is sufficient to find the joint probability because we are talking about x and y being independent. So how about this one? This range, always we know how to convert it. Probability of minimum of x comma y less than 0.5 minus p of minimum of x comma y less than minus 0.5. Okay, right. Now let us find the final answers. We have written almost the solution, but only the numerical values we have to write. So let me plot the PDF of x and y here. The given information is that x and y have same PDF, which is uniform, which takes values from -1 to +3. Height is 1 by 4. This is how the PDF of x and y looks like. X and y both have same PDFs. Now what is the probability that x is less than 2? The probability that x is less than 2 is, width is 3, height is 1 by 4, it is 3 by 4. And what is the probability that y is less than 2? That is also same, which is 3 by 4, which is 9 by 16 is the answer here. Next. What is the probability that x is less than 1? X is less than, probability is half. Y is less than 1, the probability is half. I'm just multiplying them to find the joint probability. And what is the probability that x is less than 0? Probability that less than 0. This area is 1 into 1 by 4. 1 by 4. Probability that y is less than 0 is also 1 by 4. I hope you're following. Joint probability is nothing but multiplication of individual probabilities because x and y are given as independent random variables. Next, 1 minus. So we want this joint probability, we can write as p of x less than 0.5 into p of y less than 0.5. What is the probability that x is less than 1.5? If you want it to be less than 1.5, this is 1.5. This width is 2.5 into 1 by 4 is 2.5 by 4. 2.5 by 4. And y less than 1.5 probability is also same, so it will be square. Similarly, next problem, x less than 1 probability is half, y less than 1 probability is also half, and intersection probability is half into half. Next, 1 minus p of x less than 0.5. How about probability of less than 0.5? 1.5 is the width, height is 1 by 4, 1.5 by 4. Plus this is also same, minus this will be same things multiplied. You can do the final numerical calculations. If you are able to do this till this point, that's sufficient actually. Numericals in this case it's not required, but in the exam you can do it. In the exam generally they give us some numericals in such a manner that the calculations will be generally easy. Generally, sometimes if you are not lucky, then they might give us some complicated calculations also. So how about this one? Minimum of x comma y less than 0.5 means you want x less than 0.5, y less than 0.5. What is the probability that x is less than 0.5? It is x is less than 0.5, probability is 1.5 by 4. If you want minimum of x comma to be less than 0.5, x should be less than 0.5 probability, plus y is less than 0.5 probability, minus intersection probability is 1.5 divided by 4 whole square. I'm writing the answer directly because of lack of space. Yeah, you can do the same procedure. Minus minimum of x comma y, if you want it to be less than minus 0.5, the probability is 0.5 by 4, which is 1 by 8. It will be 1 by 8 plus 1 by 8 minus 1 by 8 whole square. Next, maximum of x comma y equal to 1. Maximum of x comma y is a continuous random variable. Continuous random variable taking a particular value will be definitely 0. Or you can also write as maximum of x comma y taking a value from 1 minus to 1 plus. Okay. So how about this one? Next one, minimum of x comma y as a whole power 4 is 16 means minimum of x comma y should be equal to some plus or minus 2, right? What is the probability that it takes either plus 2 or minus 2? It also is 0. Problem looks complicated, but the understanding is very simple. And next, how about the maximum and minimum being equal to 0? Minimum, if you want this product to be 0, one of them should be 0. What is the probability that this becomes 0? With 0 probability only this becomes 0, because probability of a random variable taking a particular value is 0. So probability that this becomes 0 is also 0. Probability that this becomes 0 is also 0. The combined product becoming 0 means addition of probabilities of these two becoming 0, which is also 0. Okay, I hope it is clear till this point. I hope this class is of good value addition to your preparation. So if you feel that this class will be helpful for any of your friends, you can share this. Any doubts, you can post it in my group, Telegram group, Electronics by Dinesh Gutha sir. You can type, you'll get that. If you have any doubts, you can post it. I can help you with that, or other students also can help you with that. Okay, fine. So I've revised as much as possible regarding random variables in the previous class, yesterday's class and today's class. So if anybody has missed yesterday's class, you can go through that also. Okay, if you have found difficulty in any part of the class, just go through that part once again. Since this is revision class, I was not going into deep of the concept, but I'm revising the concepts. So wherever you found difficulty, just go through it once again. And tomorrow's class, I'll be revising random process, and also we'll be doing some problems on random process. Tomorrow and day after tomorrow, I've scheduled it for random process. We'll see how far we can cover. Okay, right, guys. Thank you. Good evening. Take care. Be happy. Don't get tensed. Okay. So everybody gets tensed, but we should come out of that tension. Okay. So too much of expectations will give us this tense situation. Don't expect too much. Okay, whatever you deserve, whatever result you deserve, you're definitely going to get it. You're not going to get a result which you don't deserve. So don't expect too much. Okay, sometimes you feel demotivated. In those situations, to remember how much hard work you have put in. So for that, you're gonna get good result definitely. Okay, don't get tensed, and forget thinking about whether the gate exam gets postponed or not. It should not matter for you. Prepare in such a way that it does not get postponed. That will leave the tension, right? If it gets postponed, that's fine. Another week or 2 weeks you'll get. You can prepare a little bit more. You can revise a few more things. Right? That should not make any difference in your preparation. Okay. So everybody in the same has everybody in this last phase will have tension. So you should tell something to yourself. You should think positively. You should tell yourself something so that you stay positive. You come out of that pressure situations very quickly. If you can't come out of it quickly, then you're wasting a lot of time. You'll not be efficient with tensed mind, right? Tension will happen only with because of expectations. Don't have any expectations. Believe that okay, I'm gonna get a result that I deserve, that my effort deserves, that my preparation deserves. Nothing more, nothing less. Okay. Thank you. Have a good day. We'll meet tomorrow again.